Greetings. I am Prajit Shah, team member of Random State 42. We have selected the second problem statement, which is optimizing sanity test performance through machine learning based risk assessment. We selected this problem statement because we were being active part of open source community. It is really beneficial for contributors to get to know if sanity check is failing or not with optimal accuracy. We have divided our code into following sections: reading the file and data transformation, which involves the pre-processing part of our data; visualizing and analyzing the data to create inferences on probability of failure; machine learning model performance, and using SHAP to visualize and analyze feature importance in detail. We are using pandas and numpy for data pre-processing. We are splitting file paths into superfile and specific file, and also removing null values. We are also performing label encoding for all the columns for data modeling. We are also oversampling the data because the dataset given was imbalanced. Visualizing and analyzing the data. We are using IPy widgets and Plotly for visualizing the dataset. These show sanity result distribution for coders. Using dropdown, we can change this. Moving on to our machine learning model. Moving on to machine learning model, we first use decision tree as base just to be able to plot the feature importance. Plotting the same, we find that specific file, sanity name, tester and coder are some of the most important features, or in other words, major players in deciding the sanity test result. We use lazy predict classifier to get an estimate of how each model performs on our dataset. In testing, both decision tree and light GBM gave similar results, but we ended up choosing decision tree as our final model as it takes less time for computation compared to light GBM. Fitting the data into decision tree model, this is the tree which gets formed. As you can see, sanity name and tester are important features here. We implemented decision tree classifier initially without pruning to see how it fits the data, and then performed post pruning alpha cut to compare it with original non-pruned model. After pruning, our testing accuracy drops to 96.56, which is less compared to our prune tree, which gives test accuracy of 97. This is our tree after pruning. Model performance. We measured performance of our model using F1 score and recall score and accuracy. This is the confusion matrix for the testing data. We finally use SHAP to visualize and analyze feature importance in detail. This is SHAP visualization for abnormal data. This can be changed using this dropdown. Similarly for pass and fail as well. Then we brought summary plot to find out feature importance of all columns. As you can see, category, sanity name, and tester are really important features. Hence, we have created a well-working model to classify whether a sanity test will fail, pass, or abort. Also, we have enhanced the model to identify scenarios which have a very low probability of failure in a particular set of